Hello everyone. Welcome to my channel Chemistry by ANR. Today's topic of discussion will be types of bonds like ionic bonds, covalent bonds and coordinate covalent bonds, which is also known as dative bonds. How these bonds are formed, what are the factors affecting the formation of the bonds, and the characteristic properties of the compounds that have these types of bonds. Hello everyone. Let us see the formation of ionic bond or electrovalent bond. Electrovalent bond or ionic bond is obtained by gain and loss of electron, and finally the electrostatic interaction that exists between the cation and the anion thus obtained. So the formation of ionic compound will depend on ease of formation of the positive and negative ion. If I say the positive ion, that is the cation, negative ion is the anion, from the neutral atoms, and the arrangement of the positive and negative ions in the solid crystalline state, that is the lattice state, how they are aligned, how strongly they are aligned. Now, formation of a positive ion, that means here if I see that formation of M plus from in its gaseous state, isolated gaseous state rather, I will say, removal of an electron in order to obtain M plus, which is also in gaseous state, that involves the ionization enthalpy, that is delta Hi is the ionization enthalpy, the energy that is required in order to remove an electron from an isolated gaseous atom. So that is known as ionization enthalpy. Now, that is the formation of cation. Anions are formed by gaining of electron, and the energy that is liberated on account of the gain of the electron is known as electron gain enthalpy. Delta EGH is electron gain enthalpy. Thus, the two ions that are formed, that is M plus gaseous and X minus gaseous, they have electrostatic interaction between them and form MX, which is an ionic compound or an electrovalent compound. So electron gain enthalpy is what is the enthalpy change when a gas phase atom in its ground state. So this is the gas phase atom. Electron gain, if I say, then this is the gas phase atom in its ground state gaining an electron. This process may be exothermic or endothermic, but in order to form an effective ionic bond, what happens is after gaining an electron, the anion thus formed should be stable. If it is stable, then the reaction is generally exothermic. The ionization enthalpy needs to be endothermic only because energy is required in order to remove an electron from an isolated gaseous atom in its ground state. So let us see the next part. Obviously, ionic bonds require what? Low ionization enthalpy and high negative value of electron gain enthalpy that I was telling you. Cations are derived from the metallic elements and anions from the non-metallic elements, because if I'm talking about metallic elements, then as per the periodic table, they should be the group 1 and the group 2 elements that can readily lose electron and obtain stability. And anions should be the group generally 17, at times 16 also. So these elements that have the tendency to gain electron and get stability, but not always, because there is some other factor which also plays its role, and that is the lattice enthalpy. That is, after the interaction between the cations and the anions, they actually form a close packed structure, crystalline structure, and orderly three-dimensional arrangement of the cations and anions is obtained. Now, this orderly arrangement during the formation of the crystal lattice actually liberates energy, releases energy for 1 mole of the crystal lattice getting formed. This energy is known as lattice enthalpy, the change in energy, that is the energy released during the formation of the crystal lattice, that is lattice enthalpy. If the crystal lattice is stabilized after its formation, then the lattice enthalpy will be more and more negative. So it is actually on account of the 3 factors that it governs whether an electrovalent bond will be stable or not. the ease of formation of electrovalent bond. That is what ionization enthalpy to obtain the cation. So the ionization enthalpy should be low. Electron gain enthalpy in order to obtain the anion should be more negative. And lattice enthalpy, that is the energy released due to the formation of the crystal lattice, should be more and more negative. Okay, so thus lattice enthalpy is an important point to discuss, and so this is what is underlined for you, that what is the meaning of lattice enthalpy. It is the energy required to completely separate. If I say to form a crystal lattice, then I will say the energy that is released to obtain a crystal lattice. Okay, now if I say energy that is required, that means in order to break the crystal lattice, to completely separate 1 mole of solid ionic compound into its gaseous constituent. That means solid NaCl into Na plus gaseous and Cl minus gaseous. Now we can see that there is a term called electrovalency. Electrovalency is a term. Now this electrovalency is related to the electrovalent bond. Number of electrons which an atom loses or gains while the formation of an ionic bond is known as electrovalency. Now, in order to form a positive atom, that is cation, there will be loss of electron, and to form an ion, there will be gain of electron. That is what it is being shown. Like electrovalency of sodium is +1 because it can lose 1 electron. Electrovalency of chlorine is -1. It can gain 1 electron. Electrovalency of calcium, magnesium will be +2. And electrovalency of oxygen may be -2, likewise. Okay. So these are the Lewis dot representations of formation of ionic bonds. See, at the top part we have the formation of NaCl, Na plus. See, it was 2, 8 and 1, losing 1 electron, it gets octet configuration. 2, 8, 7, gaining an electron gets octet configuration, and the electrostatic interaction between the cation and the anion results in the formation of the crystal lattice NaCl crystal lattice, which is a stable lattice. One thing over here you can just see examples of formation of so many ionic compounds, oxides, fluoride, sulfide, phosphide, all these things. Now it may be noted that iron has a uniform field of influence around it. Hence, ionic bond is non-directional in nature. You may be told to explain this point. Why ionic bond is non-directional? Why? Because it does not have directional character. The electron cloud or the field of the Coulombic interaction is uniform. Okay, after the formation of ionic bond, we have something called covalent bond, which is obtained by sharing, mutual sharing of electrons. By mutual sharing of electrons, a force which binds atoms of same or different elements by mutual sharing of electrons is called a covalent bond, and it was introduced by Langmuir in 1919, that we have seen. This gives rise to a term which is covalency. How many electrons are shared? That will be the covalency. This is the formation of Cl2 that we have seen over here. Now the valence electrons not involved in sharing, they are non-bonding, and if they exist in pair, they are known as lone pairs. And if they are existing as single electron, they are called odd electron. They are actually non-bonding electron because they are not involved in the sharing, mutual sharing. So this is the formation of PCl3 molecule forming covalent bond, because phosphorus, see, valence shell electron, there are 5, and chlorine needs 1 electron, 7 are there. So like this it is. So there is multiple covalent bond also. Once I told you in the previous video that if there is multiple bond, then the multiple covalent bonds means what it is. One is your sigma bond, the other is your pi bond, and again I said we are going to deal with it later on. So multiple covalent bond means it can be a single covalent bond, double covalent bond, or it can be a triple covalent bond. So they are known as multiple covalent bond. Here oxygen molecule has 2 covalent bonds. Okay, so sigma bond is one, the other is pi. Sigma bond is actually formed by lateral overlap of orbitals. We will deal with it again later on. And pi bond, sigma bond is formed by head-on overlap of orbitals, end-to-end overlap of orbitals, and pi bond is formed by lateral or sideways overlap of orbital. And whenever there is a multiple bond formation, always keep in mind that there can be only one sigma bond and rest has to be pi. And multiple bond means there can be only 3 bond between 2 atoms, same or different. Okay, why same or different? If it is N2, then it is same. If it is CN, then it is different. Okay, so next, this is the N2 molecule, and this is how the covalent bond is formed by sharing of, here we can see 3 electrons like this and existing in pairs. So I will always say draw it in this manner: 1, 2, 3, and this is 4 and 5. And here again, these are the 5 valence shell electrons. Draw it in this manner so that you can actually clearly understand how the triple bond is getting formed. So each nitrogen have unshared pair of electron, and these are the lone pairs, 1 lone pair each for each nitrogen. Covalency, I told you, it is number of electrons which its atom contributes for sharing while forming a covalent bond. Like oxygen, chlorine can give 1 electron for sharing, oxygen can give 2 electron, nitrogen is giving 3 electron. So covalency of chlorine is 1, oxygen is 2, and nitrogen is 3. Now here again, I will say these are the things, some examples, formation of covalent bonds. These are some examples: H2, HCl, H2O, ammonia. So go through this notes part. You will get it in the description part of the video, and click it and open it using your Microsoft account. If you are unable to, copy it and paste it in any of the browser. Okay, so properties of covalent bonds. Here you will see what are the properties: the state of existence. Atoms in covalent compounds, they are joined together by mutual sharing, and so they exist as individual molecules. And so you can see the type of interaction depends on what type of molecules they are. Now, non-conducting in nature. Ionic compounds, they were all conducting in nature, and here it is non-conducting. They are poor conductors of electricity. Ionic compounds were what? Good conductors because of the presence of ions. And here it is poor conductor of electricity in fused or molten state, or also maybe in aqueous state. Low boiling point and melting point, that is for covalent compounds, because the interactions are weak. Whereas in ionic compounds, they have high melting point and boiling point because the interaction is a strong interaction, which is an electrostatic interaction. Solubility of covalent compounds, they will be soluble in less polar solvents, more soluble in non-polar solvents. Whereas in case of ionic compounds, since ionic compounds have ions in them, so they will be more soluble in a polar solvent, a solvent which has a more dielectric constant like H2O. Now, molecular reactions, these compounds usually do not produce ions in aqueous solutions. Hence, their reactions are not ionic in nature. Whereas ionic compounds, whenever you take some ionic compound in a solution or in a solvent which has high dielectric constant value, it will easily and readily generate the ions that helps in reactions where the ions are involved. Now, the third type of bonding is the dative bond or the coordinate covalent bond. Okay, it was postulated by Perkins, saying that it is formed by mutual sharing of electrons between 2 atoms, but the shared pair of electron is contributed only by one of the 2 and the other simply participates in sharing. That means there are 2 atoms out of which one can be the donor atom, the other can be the acceptor. So it goes like this. Now, if A is the donor atom. It donates its lone pair to B. After the donation, those two electrons are mutually shared. So the one which is donating the electron pair is the donor atom. One which is accepting is the acceptor atom. And after the formation of the coordinate covalent bond, why it is named as coordinate covalent? Because after its formation, the electron pairs are shared. They are mutually shared. So these are some examples I have explained to you in the previous video where the topic was formal charge, and I told you what is the formal charge over oxygen atoms of ozone molecule. These are the examples of SO2, HNO3 and ammonium ion. Now, if anyone is telling you, give an example of a compound that has all the three bonds, that is ionic bond, coordinate bond and dative bond, covalent bond, that is NH4Cl. Why? Because the interaction between NH4 plus and Cl minus is electrostatic and it's ionic interaction. The bond over here, you can see these are the covalent bonds and this is the dative bond. So all the three bonds exist in NH4Cl. Moving on to the bond parameters. What are the bond parameters? The bond length, bond angle, bond order. These are all the bond parameters. Bond length is the equilibrium distance between the nuclei of two bonded atoms in a molecule. Now it depends. How do we know the bond length? Of course, we need instruments. We need technology. It is measured by spectroscopic or X-ray diffraction and electron diffraction techniques. So now it depends on what type of radius you will get. If you get a covalent bond, so covalent radius, how it is measured? It is the radius of an atom's core which is in contact with the core of another adjacent atom in a bonded situation. So obviously it exists between two atoms which is forming a molecule by mutual sharing of electrons. Okay, so after this covalent radius, we can see over here van der Waals radius. This part we have actually discussed in the previous unit where you have seen the periodic trends, and we have also discussed in structure of atom. Please go through the previous videos for better understanding. Van der Waals radius exists between molecules which has van der Waals interaction, and here we can see this is one molecule, this is the other molecule, so half of the distance it is. So the van der Waals radius is half of the distance between the two similar atoms in a separate molecule in a solid. Now this is pictorial representation of a covalent covalent radius by the formation of covalent bond and van der Waals radii. That is, van der Waals interaction is not a real interaction, but it is interaction between molecules on account of their closeness. Next, we go to the bond angle. Bond angle is defined as the angle between the orbitals containing the bonding electron pairs around the central atom in the molecule or complex. If I say H2O, that means what? It is the orbitals containing the bonding electrons. These are the bonding electrons. These are the bonding electrons. So these orbitals, the angle between them, that is known as bond angle. It is expressed in degrees, and of course it helps us in determining its shape of the molecule. Moving on to bond enthalpy. Enthalpy term actually goes with energy. So amount of energy required to break 1 mole of bond of a particular type between two atoms in a gaseous state, and its unit is taken as kilojoule per mole. How much energy is required to break 1 mole of bond in the gaseous state? That is known as bond enthalpy. So here if I say H2 gaseous, how much energy is required to break them to constituent atoms in the gaseous state? So this is the energy. When energy is required, it is always positive. Okay, so bond enthalpy of molecules containing multiple bonds should be greater should be higher, because when I talk about multiple bonds, the bond order is greater. What is bond order? Bond order means how many bonds are existing. If between H and H in H2 there is one single covalent bond, between O atoms there are double covalent bond, and between N atoms in N2 there are triple covalent bond, then over here energy required is increasing. See, 4 3 5 4 9 8 and 9 4 6, gradually it is increasing because the bond order is increasing. Okay, so let's see next thing what is over here. Okay, so let us see that this is the data about single covalent bond, double covalent bond, what is happening, how the bond enthalpy is increasing. See, CC triple bond has 120, CC double bond has 133. Now here, why it is so? There are other factors: size matching, overlapping, reactivity of pi clouds. You will study organic, there you will learn better. But here CC, when it is of same, see bond here, covalent bond length is in picometer. Okay, so this is the bond length. Okay, so let me tell you one thing, this is bond length and not bond enthalpy. And when I talk about CC bond length, so its bond order is 1, here the bond order is 2, here the bond order is 3. When the bond order increases, multiple bond, the bond length decreases and the bond enthalpy increases. This we'll see in organic chemistry, lot of application will be there. Okay, so again mark my words what I said. I said the carbon-carbon single bond has a greater length than carbon-carbon double bond, then carbon-carbon triple bond. Now bond order increases from a single bond to a double bond to a triple bond. For that reason, the bond enthalpy, energy required to break the bond, will be greater when the bond order increases. Okay, so bond length in molecules are given over here. These are the data. So here I was talking about bond order, and so here something is called mean or average bond enthalpy. When we have to break multiple bonds, we have to take the average of the bond enthalpies. So bond order means how many bonds are existing, that is number of bonds between two atoms in a molecule. And I have already told you that if I have resonating forms, regarding resonance we will discuss again. That is, if we have a molecule that can be represented in by more than one structure, then each structure is known as canonical form or resonating forms. Okay, and each canonical form have different energies and different stability. Understand that if the stability of one particular canonical form is greater, then its energy is lower. Okay, that is a concept of resonance. Here for O3 molecule, these are the equivalent canonical forms having contribution to the real structure in 1:1 ratio. So the oxygen-oxygen single bond and double bond that has a bond length, single bond has 148 picometer and double bond has 121, because bond order increases, bond length decreases. But in the real molecule, you see, it is lesser than 148 but greater than 121, which is known as a partial double bond character, where the bond length is in between a single bond and a double bond. Thank you all of you for being with me in this session. Hope you are following all my previous videos. If yes, then please like, share and subscribe.